All right, we're back in this one. Not a lot of coding, just some information coming at you. We're going to talk about advanced Boolean expressions in DeMorgan's laws. The and or logical operators can be used to chain together Boolean values, variables, or expressions to make more complex decisions. Right? We learned about our and, or, and not, our logical operators. We can use those with true or false values or even true or false expressions. Here we're using relational operators which produce true or false values, but they help us make decisions, more advanced decisions. The thing is, you can chain those together indefinitely. Right here, I'm actually using multiple logical operators in order to create a more complex decision. This could keep going. Right here it is. I'm using relational operators in combination with this, and we see the not logical operator. But here, I've got three logical operators involved in this expression. You can use these kind of to your heart's content. Whatever the decision needs to be, you can keep chaining these things together to make more and more and more advanced decisions. Generally, Boolean expressions involving multiple logical operators can simply be evaluated from left to right. So the question is then, what does this actually produce? Well, here I have true and false. That's going to give me a false value. I'm left with false or false, which is going to give me false. Here's another example. We see true and false. That's going to produce a false value. I'm left with false and true. That's going to give me a false value. Okay, here we're looking at some involving ors. We have true or false, which is going to give me a true value. I'm left with true or true. What about this one? What do you think this one evaluates to? This one's going to give us a true value. All right, let's talk about this. When evaluating Boolean expressions with multiple logical operators, it's important to know the precedence level of and, or, and not. Here is just a quick chart talking about some of the symbols that we've learned. We see at the very top, grouping parentheses. This is super important, right? Parentheses has the highest precedence, period. That way you can force things as a programmer to kind of evaluate the order that you want. Our method selector, this is whenever we're calling methods or commands. Not, here's one of our logical operators, is actually super high. We see our multiplication, division, and modulus are all on the same precedence level. Of course, addition, subtraction beneath that. Relational operators. Then we get to and or. And this is important. And actually has a higher level of precedence than or. What I'd like you to also notice is that they are beneath the relational operators, which is why we end up, let's go back to kind of an expression. Right, an expression like this, we're doing these guys before we do our and ors, that sort of thing. Maybe this one may be a better example, right? These relational operators all have a higher level of precedence than the logical operators. So these expressions, these individual expressions, actually get evaluated first, so you have the true or false value ready to go. Okay, and then lastly, our assignment operators. You want to do all of the expressions. You want to evaluate everything before you ultimately save it back into your variable. Of note, right, these things like mod equals, plus equals, minus equals, they are very low. They're on the same level of precedence, but this is also why we saw some issues with these shorthand assignment operators previously. Maybe I haven't taught you these yet. I don't even know. Okay. The important thing, what I really want you to focus on, is that and technically has a higher level of precedence than or. For most Boolean expressions, if and's higher level of precedence doesn't affect the outcome of the expression. We just saw several examples where we just evaluated from left to right and didn't care and got the correct answer. Okay, here's another example of this. On the left-hand side, I'm not even going to consider precedence. We're just going to look at it from left to right. On the right-hand side, I'm going to consider precedence, meaning this and would actually be solved first. Okay, looking at this one over here on the left, going from left to right, we have true or false. That's going to produce a true value. I'm left with true and true. Over here on the right-hand side, I'm going to consider the precedence. We have false and true, giving me a false value, leaving me with true or false. Still not considering precedence. We only got one expression left. True and true is going to give me true over here. true or false is going to give me true over here. So I did it with precedence, I did it without precedence, and we got the same thing. However, and's higher level precedence is a factor in some expressions and should always be considered. Left-hand side, same thing. I'm not going to consider precedence. Right-hand side, I am, meaning that we'll do the and first. Okay, I have true or true, giving me a true value. I'm going to be left with true and false. Over here, we have true and false. That's going to give me a false value, leaving me with true or false. Over here, we'll do true and false, leaving me with a false value. Over here, we're going to do true or false, leaving me with a true value. So we do see that precedence does matter, and technically has a higher level of precedence. Okay, one thing I will say of note, we learned about short circuit evaluation in a previous lecture, and technically this is a short circuit evaluation expression, meaning I have true or something. I technically don't even care what's over here. This is true or something. That's our short circuit evaluation. It would trigger, and we would have true. Okay, that's it for our advanced Boolean expressions. Just want you to keep in mind you can chain together those logical operators to make more advanced decisions, and has a higher level of precedence. But with that in mind, we're going to move on to DeMorgan's laws. Here's a question. What is the above Boolean expression, what is it equivalent to? Our answer here is going to be C. So let's talk about this. In logic and Boolean algebra, DeMorgan's laws is a pair of transformational laws that are used to express equivalent logical statements. Here is the actual definition of DeMorgan's laws. I'm pretty sure this came from Wikipedia. The negation of a conjunction is the disjunction of the negations. The negation of a disjunction is the conjunction of the negations. And now you get it. I don't have to say any more. I have no idea what this means. In Java, DeMorgan's laws are used whenever the not logical operator is applied to a Boolean expression. Okay. Here we see A or B, and we have a not being applied to the whole expression. Here we see A and B, and we have a not being applied to the expression. Now, there's a note here that A and B are going to be Boolean variables or expression, right? They could be true or false values. They could be relational operator expressions. I'm just simplifying them to A's and B's. So what ends up happening is this not kind of functions like a negative in algebra. We're going to take this thing and distribute it. However, what DeMorgan's laws is ultimately saying is that not only is this going to be distributed to the operands, A and B, it's also going to be distributed to the operator. However, DeMorgan's laws indicate that the not logical operator should apply to the operator as well as the operands. So I'm going to distribute this not only to the A and B operands, but also to the operator. So the question is then, what's the opposite of or? What's the opposite of and? The negation of true is false. The negation of false is true, right? It's easy to figure out what the opposite of A and B are because the opposite of true is false, the opposite of false is true. But what is the opposite of and or? In logic and Boolean algebra, the negation of a conjunction, and, is disjunction, which is or. The negation of disjunction, or, is conjunction, and. Simply put, the opposite of and, not and, is or. The opposite of or is and. So with that in mind, I'm going to take this not logical operator and distribute it to my expression. We're going to distribute it to the operands as well as the operator. I know now that not or is and. So this expression is effectively not A and not B. In this case, I don't necessarily know what A and B are, but if I could evaluate them all the way down to their true and false values, we could then solve those as well. Here, they're just placeholders. Okay, with this expression, we're going to distribute it to the operand as well as the operator, and the opposite of and is going to be or. Okay, let's get a little bit more advanced with it. I'm going to distribute this thing to this expression. We'll go to the operands A and B, as well as the operator and. I end up with this expression. We can simplify a little bit further. Not and is going to be or. I'm left with this expression. Okay. Here we go. We've replaced A and B. We're now looking at expressions involving logical operators. I'm going to take this not and I'm going to distribute it to the operands as well as the operator. The operator is this logical operator. The operand is effectively this whole expression, right? Because it's going to produce a true or false value thanks to this relational operator. Same thing over here. This whole expression is an operand. It's going to effectively produce a true or false value thanks to this equals relational operator. Let's distribute this thing. I know there's a lot of text, but we have that operand isolated. I'm using parentheses to clearly show that's what it is. I have this operand isolated with parentheses. Okay, here we can actually distribute this a little bit further, right? Well, what is the opposite of not equals? And then what is the opposite of equals? So simplifying this a little bit further, the opposite of not equals is simply equals, and the opposite of equals is not equals. We, of course, took the opposite of our and, leaving us with an or. So here is the expression as simplified as I can get it. Okay, let's try this guy. I'm going to distribute this. I'm going to simplify, leaving us with this. Okay, this one gets interesting. I want you to think about it in advance before I reveal a solution. But I'm going to distribute this not to this operand as well as this operand in the operator. So here I have an expression that I want to simplify a little bit further, right? The opposite of or, we've talked about that a million times now, it's and. That's easy. But what about this? What is the opposite of less than? What is the opposite of greater than? Be careful when applying this not logical operator to greater than or equal to, less than or equal to, these relational operators. The opposite of greater than is actually less than or equal to. The opposite of greater than or equal to is less than. So here is a chart kind of denoting those things, and I'll take a moment to explain why that is. Let's test my art skills here. All right, we got our brush. I'm gonna make it a little bit bigger. And I want you to think about a number line, right? Let's say we got 3 here. And 2, 1. Over on this side, I got 4 and 5. If I say something like x is less than 3, the way that I would visually show that on a number line is to basically have this number, right, like a circle around here, not colored in, to indicate that 3 is not a possibility, and then we would color the rest of this number line this way, right? So visually looking at this is x is less than 3, okay? What is the opposite of this expression? Well, it's effectively everything else, which means this going this way, right? And that is x would be greater than or equal to 3. So here we see the opposite of the operator, less than, is actually greater than or equal to. So when we distribute this, the opposite is going to be greater than or equal to here. When we distribute this one, the opposite is going to be less than or equal to. So there's the expression simplified as far as it can go. And that's it. That is it for our advanced Boolean expressions in DeMorgan's laws. I'll see you in the next one.